Welcome to episode 2 of AI Unpacked. So far, we've looked at where AI came from, the big ideas, the early thinkers, the breakthroughs that paved the way. But now it's time to roll up our sleeves and get practical. We'll cover how AI systems work. What are neural networks? What is deep learning? What does GPT stand for in ChatGPT? And what are large language models? Let's start with something we're all familiar with, traditional computer programs. In the old world of programming, everything followed strict rules. A human would turn logic into code. If X happens, do Y. And the computer would follow those instructions. That's it. The machine didn't think, it didn't guess, it simply obeyed. But AI, especially machine learning, changed the game. Instead of giving a computer rules to follow, we give it examples. It learns from data. Think of it like this. Traditional programming is like giving someone a very detailed map to follow. Machine learning is like giving them a compass and letting them explore. Say we want to build an AI that recognizes cats. In the old approach, we'd try to describe a cat. 4 legs, pointy ears, whiskers, maybe a tail. But cats come in all shapes and sizes. How do you write rules for all of that? With machine learning, we don't. We just show the AI thousands of photos labeled cat and not cat. It starts with spotting patterns, fur textures, eye shapes, the way ears sit. Over time, it builds its own internal rules based entirely on the data. It's learning by example, just like how very young children learn what a dog is, by seeing a few of them and hearing the word dog. No rule book needed. The engine behind most of this learning is something called a neural network, and yes, it's loosely inspired by how the human brain works. Here's how to picture it. Imagine lots of tiny decision makers called neurons. Each one takes in some numbers, does a bit of maths, and passes the result along to the next neuron. These neurons are organized into layers. The input layer is where data first enters the system. This could be an image, a piece of audio, or a section of text. Hidden layers sit in the middle and do the heavy lifting. They transform, filter, and interpret the data through millions or even billions of connections. The output layer gives the result. This is a cat. This sentence sounds happy. Each connection between neurons has a weight, a number that determines how much influence one neuron has on another. And during training, the system adjusts these weights to get better and better at whatever task it's trying to learn. The more layers you add, the more complex the patterns are that the systems can learn, and that's why we call it deep learning. One layer might notice edges in a photo, the next layer sees shapes, another one recognizes a face, and layer by layer abstraction builds until the network knows what a cat looks like. So this brings us to large language models. And a large language model is a neural network, as I've just described, with lots of parameters, often billions trained on huge volumes of text. This allows it to learn grammar, tone, facts, reasoning, and a fair bit of internet weirdness. The term large here is a moving target. Back in 2018, GPT-1 had 117 million parameters, and that was considered huge. These days, models with over 100 billion parameters are becoming the norm. The neural network architecture that facilitates LLMs is called the transformer, invented by Google in 2017. It uses attention to weigh every word in a sentence in relation to every other word, all at once. This is what makes it so good with language and able to predict the next word in a sequence. The building blocks of large language models are called tokens. If you've ever used ChatGPT, for example, you might assume it reads your message as whole words or sentences, but it doesn't. It breaks your input into tokens, small chunks of text. A token might be a word, part of a word, or even just a few letters. For example, consider the sentence, "Artificial intelligence is amazing." That might be turned into art, official, intelligence is amazing, full stop or period. Each token is represented by a number, just like every character in a film script might have a unique ID. And when the AI generates text, It's playing a kind of supercharged game of autocomplete, guessing the next token based on everything that's come before. Here's where things get really fascinating. AI is astonishingly good at recognizing patterns. That's its superpower. It sees how words usually go together. Fishan, you'd probably say chips. Bangazan, mash. It learns the rhythms of music, the style of an author, or the flow of a conversation. It finds tiny clues in data that we'd miss, whether it's a suspicious credit card transaction or a hidden tumor in a scan. But let's be clear, these systems aren't understanding in the way humans do. They're not aware, they don't have emotions. What they do have is exposure to huge volumes of data, and they've learned to imitate understanding based on patterns they've seen millions of times before. So let's move on to the GPT in ChatGPT. GPT stands for Generative Pre-trained Transformer. Generative means it can create new text, not just spot patterns. Don't be confused by the term artificial generative intelligence and artificial general intelligence. They are two different things. I'll explain what artificial general intelligence is and why some see it as the holy grail in AI in the coming episodes. Next, the P stands for pre-trained. Pre-trained means the heavy lifting happened before you ever typed a prompt. Trillions of words, billions of tokens. Transformer is the neural network architecture that looks at every word in a sentence at once and decides what matters most. And here's the cool bit. Today, anyone can build their own GPT. OpenAI's Create a GPT tool and a growing list of open source alternatives let you fine-tune a model, maybe on your company docs, the draft of your novel, even your favorite recipe cards. No tech degree required. We're now beginning to understand that AI, through a process of pattern recognition and repetition, appears to grow on its own. However, it doesn't start that way. In the early stages, humans are everywhere in the AI training process. Data needs to be labeled, filtered, and judged, and that work is often done by low-paid contractors around the world. People sat for hours labeling tweets as hateful or harmless. They marked images as violent, adult, or safe. All this human effort helped the models learn what's okay to say and what's not okay. This took its toll on many a person reviewing unpalatable content day in and day out. As AI gets more capable, the risks also grow. Early versions of AI could be tricked into generating hate speech, conspiracy theories, or even dangerous advice. That led developers to introduce guardrails, systems that steer the AI away from harmful outputs. But this raised big questions. Are these guardrails responsible, or are they censorship? Who decides what's allowed and what isn't? Should AI be totally neutral, or should it promote shared values like anti-racism and fact-based information? Companies like OpenAI, Google, and Anthropic are constantly walking a tightrope. On one side, freedom and creativity, on the other, safety, legality, and public trust. There's no easy answer, but it's one of the most important debates in tech right now. Despite all the hype, today's AI models have clear limitations. They can be confidently wrong. They don't understand truth or ethics. They can't form beliefs, hold values, or want anything. They can't cite sources' reliability unless specifically programmed to do so. These systems aren't sentient. What they are incredibly advanced autocomplete machines, powerful, astonishing, but in many respects deeply flawed. So while it's tempting to think of AI as a kind of alien mind, it's more appropriate to see it as a mirror, reflecting back the patterns and behaviors it's been shown. Understanding how AI works isn't just for engineers or tech enthusiasts. It matters to all of us. AI is increasingly shaping the systems we use every day. Whether it's the recommendations you see on Netflix, the emails that get filtered into your spam folder, or the fraud alerts from your bank. But with all of this power comes a responsibility to understand what AI is and what it isn't. It's a very complex and sophisticated tool, and like any tool, how we use it matters more than the tool itself. That's why conversations about AI are so important. The more we understand how these systems work, the better equipped we are to challenge their flaws, demand transparency, and shape the way they're used. So now you know that AI is basically maths, data, tokens, and statistics stacked in clever ways to produce incredible results. It doesn't think like we do, but it does learn from us. Our language, our preferences, our behaviors, every chat, every click, every labeled image adds to its understanding of the world. And that's both powerful and humbling. In the next episode, I'll zoom out again and explore how AI is quietly reshaping the world around us, from the phone in your pocket to the mortgage application you're submitting. See you there.